Okie dokie, everybody. We are back in the barn, and it is another cold one. So, hope everybody's doing okay. Just so you know, I have a dog in the back corner of the barn who has trapped a ground squirrel. So hopefully he will keep it down, but if you start to hear yelping, we might have to put a pause on this. And I have another dog out in the lawn going after a gopher. So it could be crazy around here. We'll see how things go. Okay, so we need to look at perimeter. So now we're into the section where we're looking at geometric shapes. So we're gonna look at perimeter, area, volume, capacity. And the thing about this is, even though you might go, oh gosh, I'm never gonna use this, but you know, we all eat things out of cans. Most of us order from Amazon, and so things come in boxes. So knowing how much you can fit in a box or how much milk or whatever fits in your carton or whatever is an important thing. So that's what these couple sections are about. Hold on one moment. Baron! Well, I can't get to him, so hopefully he'll just be quiet. All right. So, perimeter to start with. So the first thing, before we actually get into perimeter, we want to talk about some things about measurements. So the first thing to note is that measurement is never precise. Right? So the idea is that when you measure something, however precise your tape measure is, or whatever you're using to measure with, that's how precise your answer is. But you can always go with more precision. So as an example, if you were to ask me how tall I am, I would just say that I'm 5'7". I am not exactly 5'7". I might be 5'7" and a quarter. But even then, I'm probably not 5'7" and a quarter. I'm probably 5'7" and a quarter and a little less than a quarter. But depending on what I use to measure my height, how precise the instrument is how precise the measurement is. Baron! Okay, so precision relies on the instrument that you are using, which means that we don't want to do too much rounding. So if we do have to do rounding, always remember that rounding should be your last step. So rounding should be the last step to be as precise as possible. So the idea is we want to be as precise as possible. And the best way to do that is to leave the rounding until the very end. And you'll see what I mean as we go through this, okay? Okay, so when we talk about perimeter is a linear measure or a linear dimension. So we say the number that represents linear dimension is called length. Now, we do hear things like length, width, and height, and those are all linear dimensions, okay? They are linear or one dimension or two-dimensional measurements, okay? But the kind of basic word that we use kind of as an all-around word is the length, okay? So it seems weird to say, like, if you ask me how tall I am, you don't say, what's the length of me? But essentially that's what we're doing. We're figuring out what the length is, okay? So length is what we're looking at here. Now, perimeter then, let's define that. So the perimeter of a polygon is the sum of length of all the sides. Okay, so let's see what they ask us to find the perimeter of. To the right page here, 454. Okie dokie. Okay, so let's say that they gave you a triangle. There's our triangle. And they're going to tell us that's 3 meters, this is 4 meters, and this is 5 meters. Okay, if we want perimeter here, okay, we'll call it with a capital P, and we want the length of all the sides put together. So we're going to go 3 plus 4 plus 5, which will give us 12. And don't forget to hit your answer with your units. So this one was in meters. So as long as you have all of the sides of a shape, a polygon, then you can just add them up and figure it out. You don't really need any special formula. Now, when you do have a rectangle, with a rectangle, a lot of times we consider this side to be the length and this side to be the width. Now I know it doesn't look like it in my crappy rectangle that I just drew there, but the length and the length should be the same, right? And this width should be the same. So in this case, when you look at perimeter of a rectangle, it actually does give you a formula. So perimeter of a rectangle is P equals 2 lengths plus 2 widths. Okay, so there are 2 lengths and there are 2 widths, so you're adding them all together. But again, as I said, as long as you know the measurements of the different sides, you don't need the formula. If you want to use the formula, have at it. If you just want to add the sides together, then that's fine as well. So if we've got a rectangle and it tells us that this is 4 feet and this is 2 feet. Now again, it didn't give us all 4 sides, but the assumption is that if this is 4 feet, that one is also 4 feet. So if we want the perimeter, we can go 4 plus 2 plus 4 plus 2, right? Just go boop, 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 all the way around. Hey, look at that, it's 12 again, which gives us 12 feet. Or you can use our handy formula. You can say 2 times 4, right? 2 times the length, plus 2 times the width. So 8 plus 4 is 12. So it works either way, okay? So again, as long as you have the dimensions, meaning the length of the sides of the shape, you should be able to find the perimeter. So perimeter is not one of our super challenging ones, but let's see what we have here. So they give us a little word problem. And again, the word problems that we're doing here is just to show you how some people do use this. You might use this. In this case, we're putting up fence. Okay, so suppose you have enough material for 70 feet of fence. Okay, that is not how you say you. You have 70 feet of fence. Okay, and Baron, and want to build a rectangle 14 feet wide. Okie dokie. What am I looking for? What should the length be? Okay. So I don't know, the side of your yard is 14 feet wide, so you know that you're looking at 14 feet wide. That one is set in stone, but you need to figure out how long that's going to allow you, and you go out and you measure and you have 70 feet of fence. So this would be a good example of when to use our perimeter equals 2L plus 2W. And you can also draw yourself a little diagram there. There's your rectangle that you want to build. And you know that the width is 14 feet. And we're looking for this guy. How long is it going to be? So we know that the perimeter altogether is going to have to be 70, right? Can't be more than that because you only have 70 feet. So we'll say 70 equals 2L plus 2 widths, but we already know that our width is 14. So yes, a little bit of algebra skills here. So 70 equals 2L plus 28. So we will subtract the 28 from both sides. So we end up with 42 equals 2L. And when we divide by 2, we get that the length is going to be 21 feet. Okay? And don't forget to make sure you put units on there, okay? So this person is able to know that if they're going to go that 14 width, that they're going to have they're going to be able to have 21 feet in length. Okay? So it gives you a little bit of information when you go to set up for your building your cage or yard or garden or whatever it is. Okay. So polygons, again, adding the sides together, not a big issue. But, excuse me, not all shapes are polygons, okay? Not all shapes are polygons. What if we have something circular, okay? So we got to be talking about circles. And in circles, you could say to find the perimeter of the circle, but the word that is used is the circumference. So the circumference means the distance around a circle. Okay. And circumference does have a formula, okay? It's not just adding sides together because a circle doesn't really have sides. So circumference will go with C, and circumference is found by taking, there's two ways to write it, either 2 pi r or d pi. Okay, where r stands for your radius and d stands for your diameter. So here's our circle. Okay, if we go just from the center out to the side, this is the radius. If we go all the way across, so from one side to the other through the center, that is the diameter. All right, so somewhere in your math career, you have been taught about pi. Okay, so pi is the number 3.1415962, blah, 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 blah. Okay, it goes on and on forever and ever. And it comes from the circle. And so what we have here is we've got this idea of multiplying by pi when we're looking at circumference of a circle. All right, so again, these two formulas, they're both the same. It just depends on which one. I tend to use the one with the r because as you go further with math, we kind of forget about the diameter and we only focus on the radius, but it's completely up to you. Now, there are two ways to do this to leave your answer. If you choose to, you can leave your answer with the pi in it. But if we are trying to take this like to find the length or the cost or something like that, then we're going to want to multiply with the pi. Now, for most of you that are using a somewhat scientific calculator, you have a pi button. So I know most of you aren't using the graphing calculator, but if you are, your pi button is going to be over here, and you go second pi. And the idea is when you put in second pi, it's not just using 3.14, it's using 3.141592654, and again, goes on and on forever and ever. But at least you're getting a lot better rounding when you use your pi button. If you have the little scientific calculator like a TI-30, you probably have a pi button as well. You just have to kind of search around for your keys and see if you can find the pi, because that's the one you want to use. Now, if you got just the little, regular old like solar guy, then then you're probably going to need to use 3.14. Okay, so you can make a little note of that. Remember that pi, if you need to, we can abbreviate it as 3.14. Okay, so let's see what our problem looks like here. of a circle with a 40-foot radius. Now, if they don't draw you a picture and they actually write it out in words, your best bet is to give yourself a picture, okay? Draw yourself a little drawing. It doesn't need to be good. No one said you have to make perfect circles or anything. And label what you're given, and be careful. This has given us the radius, which means it's given us just from the center out. Okay? We do not, they didn't give us the diameter, they only gave us the radius. So as I said, I normally use this formula because it's the one with the radius in it, and this is the time when we're going to do that. So we're going to say C equals 2 times pi times the radius. So if I was just in a math setting, I would leave this as 80 pi. Okay, 2 times 40, 80, and just leave the pi and stick feet on the end there. So if I was just in math class, not out in the real world, this is the way I would leave it. But if you go to somebody and you say, oh, the circumference or the distance around that circle is 80 pi, they're going to be like, 80 pi is what kind of pie? Cherry? What are you talking about? So if you're giving a real world example, you might want to multiply that out. So when we go 80 times pi, we get 251.33 feet. And so that's more clear to people in the real world. They don't have to worry about what you're talking about with pi. Okay? All right? Okay, so let's say that they gave you that much of a circle, and they told us that this was 10 inches. Okay. All right, so if that's 10 inches, and I guess this has to be 10 inches too, right? Then they want us to find the distance around this shape. So find the distance. So we've got a little bit of an issue on this guy in that we know these two sides, don't we? But we do not know the curvy side, because the curvy side is part of a circle. So we could find the circumference of the whole circle, okay? So let's look at a whole circle. The circumference would be 2 times pi, and then isn't that the radius again? So this would be 20 pi. Okay, but that is if we were looking at the whole circle going all the way around. How much of the circle are we just going? Okay, we're not going the whole circle. Are we going 1/4 of the circle? So we want 1/4 of the circle. So what we're going to do is we're going to take the 20 pi and divide it by 4. We want just 1/4 of it, which will leave us at 5 pi. Now, I don't know why I didn't write that higher. Come over here. If we want the perimeter of this weird shape that they've given us, we know that we're going to have one side of 10, another side of 10, right? 10, 10. And then we know that that 1/4 of a circle is going to be 5 pi. So again, if I was just in math class, I would just leave it as 20 plus 5 pi inches. That's perfectly precise. Nobody needs to worry about it. But again, in the real world, people are like, I don't know what that means. So we can go 20 plus 5 times pi equals, and we get 35.71 inches. Oh, right. Look good for that one? So circumference going all the way around, but there are going to be times when we're most definitely going to use parts of the circumference, like half of it, or in this case, 1/4 of it. So you got to be ready. You got to be ready for examples like that. All right. We good with perimeter? So perimeter and then circumference if it's a circle. And that's it. Sound good? All righty. We'll be back next time with area.